Yell at them till they submit.
Yeah, definitely use your muscle. Yeah. The opening statement. This presidential election is leading to a shit show. Sorry, not sorry. I'm just saying I'm not conscious. Anything you'd like to talk about? How fun. Let's talk about
What?
rabbit on my jacket.
Oh.
Yeah.
Okay, I'm officially going to start before I go crazy today. Welcome back. A couple things to get off my mind here so I stop thinking about. The first is the fall break is next week. So this will be our last class meeting until after fall break, so don't come to class Monday. We will be meeting Wednesday as normal and so forth. Periodic table extra credits. I forgot when it's due, but sometime soon. Next Wednesday, okay, if you would, hand it in there. And then extra credit for the second exam is going to be due like a week and a half from now, 2 weeks from now, somewhere around there. Now that one is finding a Nobel laureate and basically doing a one-page clipping about the Nobel laureate. So half being what the person received their Nobel award for, and then the other half being your thoughts on it. Good, bad, indifferent.
Is that from this year or?
Any year, any category.
Wait.
Find one you're interested in. I could randomly assign her or something, but the chances of me being able to pick ones you're interested in is probably pretty small. If I had my choice, well, first I'd make everyone do chemistry, and then I'd make everyone do probably literature. So those are my announcements, I think. Midterm scores will be turned in shortly for everyone. I'm waiting to get the final ones from the lab because you guys took your lab midterm this week in 105. So that's where we stand with that. Okay. Questions? This whole starting late thing's throwing me for a loop. No, it's just kind of weird.
Like 5 minutes.
I know.
6 minutes?
You're not counting. Okay, so what I thought we would do then is last time we did a lot of work with ionic compounds. And we talked about ionic compounds, and at the end of class we did the crossover trick to look at the charges and find them. Is that correct? Sound familiar? Yes, no?
Yes.
Okay. But I felt like we hurried through it all to some extent, so I want to go back and kind of look at it again and work an example to kind of bring everyone up to speed for today as we go through it. So what I'd like to do is look at the reaction between beryllium and chlorine. So beryllium is going to react with chlorine to form a compound out of this. Now, I know we've got several ways to do this, but the first thing that I want you to do, one, is predict the compound that forms using dot diagrams. Now, did we do an example of this in class using dot diagrams to predict it, where you move the electrons over? Yeah, okay. So let's go ahead and see if we can predict the compound that's going to form between beryllium and chlorine using dot diagrams first. let's say 30 seconds or so to get your ideas down. Okay. Everyone got their ideas? So we're going to start out with beryllium. And how many dots am I going to put around beryllium for its dot diagram? 2. 2 indeed. It's in the second column of the periodic table. So it has 2 valence electrons. 2 valence electrons corresponds to the 2 dots. Then we have chlorine. And how many are going to go around chlorine? 7. So here we are, and we need to fulfill the octet rule. So beryllium is going to donate 1 to that chlorine. Now when it donates 1 to the chlorine has fulfilled the octet rule, and it's perfectly happy. Is the beryllium happy just giving up 1?
No.
No, it's not. It needs to give up 2 so that it can get rid of its shell. So it's going to find another chlorine atom. And donate that electron to a second chlorine atom. It can do this because when we react things together, we can't just pick up one atom of one element and one atom of another element and put them together. They have to actually be thousands and thousands and billions of these things all together at a time. Remember how small atoms were? We can't go in and just pick up individual ones and put them together. Okay? Since there's always a lot of them around, you can always just find another chlorine for that to react with. So if for every 1 beryllium it takes 2 chlorines, the compound that forms is going to be BeCl2. BeCl2. Questions about that? Okay. Now this is, starting out the dot diagram, the most, I actually think it's the simplest form of predicting it, because you're really just moving the dots around to fulfill the octets. But it also takes the longest amount of time. So you only really need to do the dot diagrams to predict products when I ask specifically for it. I'll say something like, using the dot diagram, predict this, or something along those lines. If I just said predict the formula, then you can do it however you want. But in this case, I'm going to say use the crossover trick. To predict the product. Okay. Now this one should take you significantly less time because you're not drawing everything out, I guess. But you do have to know the charges for things. So what charge does beryllium take on when it goes into a compound? Anyone remember? +2? +2, and that's right. Because it's going to give up 2 electrons. And when it gives up 2 electrons, it's giving up 2 negatives. Since it gives up 2 negatives, it's going to end up as a +2. Chlorine, on the other hand, is a halogen. And the halogens end up taking on 1 electron. So it becomes a -1. +2 and -1. Basically, it's what has to happen for it to fulfill the octet rule. Then for the crossover trick, we're going to bring them as subscripts. And generally, chemists leave the 1 off. So we again find the same thing, BeCl2. Now, as you go through this, you're going to learn it's true, but it's kind of easier just to remember it. If you look at the periodic table, the charges, this one is +1, this one is +2, this one is +3, This is going to be +4 or -4. Then we start at the negative, so -3, -2, -1. So going across the table, +1, +2, +3, +4, -3, -2, -1, and then 0 on the end. Okay? So you can kind of remember it that way as well for the non-transition metals. So wherever it sits, you just know the charge. So polonium, 84 here, it's under oxygen, it's in this one, so it's going to be a -2. Straightforward like that. Okay, beryllium then, second column is +2, chlorine, seventh column, it's a -1, so you just can remember that. Okay, let's try another one. Let's do gallium and sulfur. And you could just do the crossover trick if you want. I guess I'm not checking either way. So. Say another 10 seconds or so. Okay. Anyone feeling brave and want to share what they got for an answer? No? Oh, okay.
So gallium has +3
Okay.
charge, and sulfur has -2 charge.
-2.
Then we cross it over to be thorium 2 and sulfur 3.
Yep. Gallium 2, sulfur 3. Perfect. Questions about that? So we're starting to get into some material that's new for people and so forth. And I really want to stress to you guys that you keep up with the materials we're going through. So for example, on this one right here, the answer, gallium-2 sulfur 3, can be traced all the way back to when we figured out how many protons, electrons, and neutrons were inside of an atom. So inside the atom, it's made up of these components. That then led to the Bohr model. The Bohr model led to the valence electrons. Valence electrons led to the dot diagram and the octet rule, and then that led to our product. So these things are building upon themselves, and we're going to continue doing this throughout the chapter. So this class has been great about attendance and everything. I'm not going to even harp on you about that in any way, shape, or form. Just make sure like you're keeping up on things. In my other class, I had a student who showed up after missing 2 days, and they hadn't covered any of the ionic stuff. So when we jumped into this part, coming up with formulas, obviously completely lost. Okay? They're going to have a hard time catching up. So it's just important to keep up with the material and so forth. It's really, really easy to get in a hole and not be able to get out of. But for now, we're good with Ga2S3. Is that compound going to be ionically bonded or covalently bonded? Ionic, and why do you say that?
Because it's a metal and not metal.
Exactly right. Exactly right. Gallium is a metal. Sulfur is a nonmetal, so that means it's going to be ionic. Okay, and ionic bonds. The other thing is we have charges here that they take on, meaning that they form ions, so that leads to ionic bonding there. Okay. Do you guys feel comfortable with predicting products that come out of these? Yes, shake your heads, yes, no, I don't know. There's really only two ways to do it. Okay. Got a few smiles, that's all I care about. So once we can go through and figure out the naming of it, Just realized when I was here, the lights are on. Does it care if I turn off the lights? Fall asleep. Once we can go through and predict the products that come out, we want to be able to name them. Now, naming chemicals and products like this may seem like it's very, very complicated, but it's not. And to be honest, you guys actually know a lot of the names of these things, whether you realize it or not. So table salt is sodium chloride. Okay. And that would be the name of it there, and you're probably familiar with that. Magnesium chloride is the next one over there. So when we're going about naming them, there's two basic rules we want when we're naming things. The first one is that the cation name stays the same. So whatever your first element is, that first element's name stays the same. And then second, says that the anion's ending, so the anion or the second element's ending changes to an IDE. And really, this is the basic rules for ionic compounds. As long as your compound is ionic, then these are going to hold true. So if we come over here to these examples, Be is the first one, so that's going to stay the same. Wish I could remember how to spell beryllium. I've completely blanked. Wait, I got a periodic table. I can do this. Okay, beryllium is Beryllium. So that's going to stay the same. And for our second one, that's going to be gallium, which is going to stay the same as well. And gallium has two L's, of course. Got it. So beryllium and gallium. Now, that means the cations stay the same. The anion ending is going to change to an IDE. So we start out here with chlorine, and we're going to change that ending to an IDE or chloride. Chloride. So the name of BeCl2 is going to be barium chloride. Barium chloride. Make sense? Yeah.
Do you ever put the chlorine in front of the B, like Cl2B, or is it always the
In chemistry, what we
metal always goes first?
We list metals first, because they're the cations in this case. But as a general rule, whichever element is furthest to the left on the periodic table gets listed first. There are some exceptions to that, but generally that's the idea. So the Be will be first. Now if you reversed them and you wrote chlorine berylliide, I'm probably going to accept it anyway. Just because you showed that you knew the rules, you just got confused on that convention part of it. In terms of naming, there's a lot of those types of things that we're going to talk about. So the second one, for example, is gallium, and it's sulfur. That's going to change to sulfide. So the name here is gallium sulfide. Gallium sulfide. Seem good? 2 rules. First one, it's not really a rule, the name just stays the same. Okay, so let's have you guys try a couple of them. First off, let's do Al2O3 and Ca N. So it's going to be Ca3 N2. Aluminum, oxygen, calcium, and nitrogen. Okay, everyone got their ideas? So Al2O3, Al is going to be aluminum, and the O3 is going to be oxide. So the name of this one is going to be aluminum oxide. Then over here, the second one, Ca3N2, is going to be calcium. And then nitride. Calcium nitride. So nitrogen gets shortened down to nitride. Yeah.
So besides the carbon family, we say B plus 4 minus 4, but this rule's only affecting what, about 15 elements?
Which rule? The IDE?
The IDE.
Yeah.
Okay.
Yeah, 'cause they're going to be the non-metals
They'll never be, yeah.
associated with it. Okay. Do you guys feel comfortable with that? Yes? No? Okay. Okay, so let's do one more example here. Okay. And we're going to say, we're going to react lithium and nitrogen. Lithium and nitrogen. So predict the product that would form between lithium and nitrogen, and then name it. So the product between lithium and nitrogen is going to be Li3N. Li3N. Is that what everyone got? No? Okay. And then the name for this is going to be lithium nitride. Lithium nitride. That's the name. Okay. Everyone agree with that? Okay. So what about if we're going the other direction? Instead of going from the formula to the name, what if we're going from the name to the formula? So for example, if I was to write calcium chloride. Calcium chloride here. How would you go about figuring out the formula for this? Well, the way you're going to do it is first, you figure out what elements are involved in the bonding, or in the compound. It's going to be calcium and chlorine. But the thing you have to do and make sure of is that the charges balance one another. So what charge does calcium have in a compound?
Plus 2.
+2. And what chlorine is a -1 still. So you have to remember to bring these down as subscripts. And CaCl2. CaCl2. So let's have you guys give one a try. Let's do sodium. Sodium oxide. Sodium oxide. Sodium oxide then. Everyone got their ideas? Oh, yeah.
I have a question.
Okay.
So sometimes you write like 3 negative.
And -3.
Okay.
Yeah.
So like, is it okay if we put like?
Either one is perfectly fine.
Okay.
Chemists traditionally will write the minus after and the plus before, but it really makes no difference at all. You can put it before or after. They're exactly the same thing.
Okay.
Yeah. I knew immediately once you started asking. I do it because I don't even think about it, but that's just the way it is. Yep. Okay, sodium oxide then. Sodium is going to be Na. Oxygen is going to be O. And the final product that forms here is going to be Na2O. Na2O. Good with that? Okay, so here's the situation. I got a text. My kid is sick, actually. So the question is, do you guys want to go for like another 10 minutes and stop before I have to go get him? Or do you want to stop now? Or should I try and find someone else to come in?
It's up to you.
Yeah.
I mean, I feel bad for you guys walking over here, but getting a text in the middle of class is kind of middle of class.
If your kid is
This is
sick,
a bunch of kids.
I know, but, because this is the best spot to stop probably for the next while. So let's call it now. I'll go get my kid and so forth. This doesn't sound like anything serious, it's just running fever. Okay, I apologize for making you walk over here and sit in the hallway and wait for the class. Of course. Go. Fascinating. No. Not in here. No, that's a little bit beyond the class. Here we go. How are we going to die? We will. And that's, we use those. Oh, did you? Yep. No problem.
They're gonna lay right under you.
Yeah, and they said once we got it down, so we need to continue going, that's what they said. And they said, well, that's kind of rude. It's like, and we're like,
This is bad. Oh, jeez. Okay, I'm on my way. Oh, that's right.
oh, yeah. Sophomores don't want to do all the work themselves.